Wei got her PhD at NYU and and did a postdoc at University of Pennsylvania, taught at Ohio State, visited LTI in summer 2019, which seems like decades ago already, although it's not so long. And now she's teaching at Georgia Institute of Technology in the School of Interactive Computing. She works on many exciting topics such as generation, extraction, text simplification, reading support, social media, and she has won awards such as the National Science Foundation Computing Research Initiative and Crowdflower AI for Everyone. And we are so happy to have her speak here. Her title today is The Importance of Data and Linguistics in Neural Language Generation. Okay, so please go ahead, and thank you for accepting our invitation to speak.
Yeah, thank you for inviting me. I kind of was like all the pictures I have, memories I have about Gates Center kind of flashing out, and kind of feel I'm in Pittsburgh right now and seeing many familiar faces and new faces. So my research kind of covers several areas, primarily in generation and semantic for understanding, as well as a lot of work in social media by my student. Today's talk just going to land on this part of my work. Now jump right in. So I'm going to talk not only text generation, but I want to talk one particular type of generation that this is actually my favorite text generation task. It's called text simplification that Laurie just mentioned when introducing me. So if you are not familiar with the task yet, let me just walk you through what it means. It's primarily just like rewrite text, for example, Wikipedia document or like news articles into a simpler language with simpler word choices and simpler grammars, while retaining most of the original meaning. So here is a news article, just like I'm just picking one paragraph here. If we take a closer look, these are two sentences. The professional editors would rewrite these sentences in order to help, for example, K-12 schools to use the news article material in the curriculum. So this is basically, you can actually ask professional editors can convert the concurrent, the new news articles in order to do this, right? So it's kind of pretty involved. There's including some sentence splitting, a significant amount of lexical paraphrasing as well as syntactic paraphrasing in order to achieve this task. And of course, there's some reordering happening as well. There's one startup company I found in 2014 when I was looking out for this task and looking for data. I was totally ready to create a crowdsourcing a large data set by myself. But after 9 hours, I think, or 7 hours of Google search on like page 50 or something on the search result, I found this company. Which is based in New York and San Francisco. They had only 20 person at the time. Now they have 400 employees as I checked. So what they do is they actually hired a troupe of professional editors actually converting this news article for the US K-12 schools. As the company claimed, they now have more than 1 million of students in the US using this. The nice thing about it is like they actually not only rewrite news articles, they actually rewrite into 4 different readability levels for elementary school and middle school kids, covering a lot of different topics. So why we do this? This is similar to machine translation, right? You want to help people to read, and instead this is not translating from a foreign language to English, but it's translating complex English into a simpler English. It helps children to read and help like non-native speakers, as well as help people with, who are deaf and hard of hearing students. So my collaborators at RIT actually tried out our techniques with a real human subject. There's other work on Relo, who was a postdoc at SMU with Jeff Beacom. She actually did some work with applying text simplification technique to see how to help like people with dyslexia. It also can help everyone, not only people who has disabilities or who are children, but can help anyone who to read those very difficult and like legal and medical documents. As a non-native speaker myself, I still today, after living in the US for more than 10 years, I still have hard time to read medical documents. And then I asked some native speakers, and clearly they also have difficulty to read those. So speaking how we do this automatically, so we clearly know what the goal is, and now similar to machine translation, you can clearly say whether the system output are good or not. The difficulty is how to exactly mimic the same capability as professional editors to achieve this task, right? So it's a very complicated rewriting happening. The reason I like this task, like from technical point of view, is almost like your ultimate text-to-text generation task, right? That requires splitting, requires compression, similar to summarization, require like paraphrase generation, not only on the lexical level, but on the syntactic level. And it's if you consider readability level as a style, it's actually a very rigid style transfer task. So kind of a more like an umbrella test, like evaluation can test all this capability of your generation models. It does require a lot of diversity in the output, as well as a lot of controllability in this task as well, right? So non-native speakers often prefer the longer output, but returning as most of the meaning. While like the children, depend on their age, they may like prefer the sentence to be shortened, right? So actually different user will want different things. So it's like also a perfect test to test out the controllability of the neural generation models. There are also fairly good, very good training data because we discovered this company, and there's also people have been using Wikipedia. I will talk actually later part of my talk, going to go through how good the data are. Given it's pretty sizable, the quality are pretty good. Given our this year's new work, we fixed the quality issues. There's kind of a fairly good evaluation because this can be evaluated by any English speaker. Will be actually give a fairly good evaluation, manual evaluation. And I'm also going to talk about an automatic evaluation metric I created called SARI, which is not perfect, but it's going there. So that leads to the outline of my talk today. I'm going to primarily talk about the how to design a controllable neural generation model, as well as how we created a very high quality training data for doing this. So these are the work primarily done by my PhD student, Chao Jiang, Monica Mandela, and Yang Zhong. So I want to discuss like how we can incorporate like linguistic rules with neural network models. I also want to actually demonstrate that the performance gain from improved data actually a lot of times much significant than improving the model getting more complicated architectures in a lot of cases. There's a lot of previous work we have done that lead to this point for this tool more like a breakthrough work this year. So if you're interested, I'm going to touch on some of these works and throughout my talk. My group actually work on many different natural language generation tasks. I don't have a lot of time to talk about it today, and many are ongoing work. I just want to hint on what kind of generation tasks that's kind of interesting. So one work is a collaboration with Li Yang, who was a former PhD student at CMU LTI. It's like neutralizing biased languages. So we kind of try to automatically neutralize the biases to a more neutral tone. And my other PhD student, Chao Jiang, is working on scientific rewriting, how to write paper better. I guess at some point, I got a little frustrated to revise my PhD student papers. And then I asked them to basically build an automatic generation tool to help with writing, which I think is going to be pretty cool. Some other collaboration with CCB at Penn and his student is actually dealing with monolingual task. We are probably going back to work a little bit more on style transfer. I think I did actually work on style transfer before it's cool and before it's even called style transfer in 2012. So John Waiting at CMU, who is graduating, I think this year, actually had a very nice paper at EMLP 2020, just next week, with multi-year style transfer. They were not only transferring from like for me, is like I did a work is transforming normal contemporary English into Shakespeare style. What they did, they actually did it much more ambitious. They kind of convert like Twitter data into Shakespeare style, and then from Shakespeare style to Twitter and any direction and any kind of genre. All right. Very brief history before we jump into the technical part. So a lot of study in the late 1990s and 2000 done primarily by linguistics that created a rule-based system to tackle this problem. And then from 2020, there's a big thing happen is that simple English Wikipedia become available. So everyone for here use English Wikipedia. Let's know is like Wikipedia has a version is actually written in simple English, considered simple English as a language, as Arabic and other languages. So this is English is the only language have a simpler version of Wikipedia. So that provided parallel data. That make it possible to derive parallel corpus like sentence pairs, just like machine translation models. So people were able to apply static machine translation system to do this more like a data-driven method. In 2015, we published a work on using this new SARI data, which is kind of more like a professional editors. So that faced a lot of issues from the Wikipedia data that had a lot of quality issues. I'm going to talk a little bit, the second half of my talk will go to primarily discuss the issue in the data. So what blocked the people have been able to do this, like from 2010 and 2015 to make progress is really the issues in the data that prevented any advances in this area. So that's kind of fast forward. Once you have good data, you can train your favorite neural network generation models. This is how it's been done today. So the first work that applied neural networks to this task is in 2017. So it's kind of fairly recent, only less than more like 3 years ago. And the first application of transformer models is actually in 2018 from a set of researchers at University of Pittsburgh, kind of across your street. However, if you look closer at all this, like after that, there's an even more state-of-the-art model being produced, more complicated versions of it in the past 2 years. However, if you look at this like state-of-the-art generation models, they will actually primarily doing deletion. They rarely split sentence. They rarely paraphrase it, and even they do, when they do kind of create some errors. So most of the errors from these models, even the model we're having today, is a substitution. So sometimes the substitution makes sense, but not making sense in the context or when they compose as an entire sentence. But before our work, this year, most of the these are the state-of-the-art model people have had the year before 2019. You can see they kind of shorten it. You can see where this comes from, right? So the original sentence is according to Lanford, this a person. Northrop executive said they had built substantial part of the bomber in Palmdale. You can see this is kind of doing it. It's Lanford is a big group of bomber in. So they pick the word, right? It's still very fluent, it's very grammatical, but it just no longer carry the same meaning of the original sentence. There's many reasons of it. Again, data is a big issue, and then the other side, shortened sentence is the easiest way to trick both human evaluation and automatic evaluation, right? So if you deleted the second half of a sentence, you're more likely to kind of at least being considered as simple by the human evaluators. So those kind of by the current evaluation setup does give prefer the sentence, prefer the sentence systems that are more conservative at generating paraphrasing, but prefer the deletion, which is like potentially be more reliable or generally easy to do. Take a slightly closer look at this. So this is our how the state of our system does compared to the professional editors, right? So the professional editor doesn't compress the sentence as much, especially for a normal readability level. And professional, and also you can see many of these neural models almost keep the output identical to the input by copying exactly the same sentence. But in the evaluation, they still can get a fairly good good scores because they keep the perfect grammar and meaning preservation. And they don't normally split, right? And they introduce very fairly smaller amount of new words. Basically, they rarely paraphrase compared to professional editors. So in fact, professional editor actually does a lot of much more significant rewriting. So this is kind of more like a breakdown, and also the size of data we are training on today. So it's fairly sizable. It's about 500,000 of sentence pairs. But there's at least 20% of splitting that the previous model are not doing, right? So this is a kind of background of what's going on. I'm going to jump into our newer work. This where just wrapped up pretty much this week. So the master, we want to really control the generation process. We want to be not only doing kind of deletion, we want to be able to generate, to do splitting, doing deletion, and also control the amount of paraphrasing we are doing, right? So there's many kind of knobs you can try to control in this, instead of just training a model that end-to-end and doing this black box. So we ended up this current design is more like a pipeline style. In order to incorporate like linguistic or motivated rules into the system. So there's 3 steps. I'm going to walk through each of them. So the first step is that we try to doesn't consider a lot of rephrasing, but instead we let the model focus on splitting and deletion, right? But of course, deletion is related to splitting, right? Pretty much you can split a sentence and then delete one of the sub sentence to achieve the deletion. So we cannot do this together. One thing I want to point out, the rule-based system works great for splitting. So this is a set of linguistics in Europe and Switzerland and Germany and UK. They had a new paper last year doing sentence splitting based on the parse tree. So they only have 35 grammar rules, but they work really great. There's actually a series of work, and there's actually in the history, there are about 5 group of researchers has attempted a rule-based system for doing this, but this one from last year is one of the best. We experimented that on the news article sentences that if the sentence are longer than 20 words, and the system will successfully split 92% of them and only introduce 7% of errors, able to insert a pronoun or the noun phrases correctly. So I do want to advocate for the rule-based systems. It's not entirely has to be a rule-based system. You could train a seek-to-seek models on the data we have that contain the splitting and deletion in order to do this. But if you combine the 2 together, they will work even better. Just a quick note in terms, in case you're interested in this, this rule-based system also available for German. They actually do it recursively. I will show you just in a second. So they have, given a long sentence, they will apply rules like recursively that taking this discourse into account. they will split the sentence like this into two, and then they will continue splitting until to the minimal component. That's give a lot of flexibility to design our model. So we will just pick on any kind of sub-traits that make sense together, doesn't overlap, to compose this intermediate result. It's just a different way to compose all these sub-sentences. Again, it doesn't has to be a rule-based system. We just think this is work great. It could be just you use a seq-to-seq model to replace this process. So then we have all this like intermediate kind of result that doesn't contain a lot of, doesn't contain much like lexical rephrasing, but primarily syntactic structure changes. Then we want to rank them. So the ranking have two purposes. So primarily the ranking are trying to finding the ones that closer to the human references. There are two purposes of this. The first one is like the top ranked intermediate candidate will be used for the final output of the system. And another purpose of this is we want to do data augmentation to improve our paraphrasing part. So basically this is taking away, especially the top ranked one, they are taking away the deletion problem or splitting problem. We are trying to find the intermediate candidates that primarily focus on the lexical paraphrasing or reordering instead of deletion at the same time. So we were able to offload some of the burden of handling all this several combination of several operations at the same time. So we pick the top ranked part that's similar to the human references and create our parallel data to train the paraphrase generation models. So the ranking is done as a pairwise ranking models. So the input to the model is two candidates. So two candidate intermediate output. Then we kind of rank that which one is potentially closer to professional editors, right? So during the training time, to create this, the gold scores. So the way to measure the goodness of the candidates is to test out the board scores. So board score is kind of a hybrid, I would say hybrid of blue score plus board. So they kind of also consider n-grams, but they compare the n-gram at, they did a little bit word alignment and compare basically the board embedding similarity between the n-gram to calculate this. So so the board score will capture the similarity between the candidate and references. However, board score itself doesn't have a length penalty. So we did introduce a length penalty in order to find the candidates that are closer to the human references, in order to find those candidates that capture more paraphrases other than the deletions. Any questions so far?
I was wondering if you could talk about the complexity of the human-written, handcrafted rules. For example, I noticed that they filled in relative clauses. I forget what the sentence was, but you'd have to know what the head of the relative clause was and fill in the gap. So how complicated were the rules?
I found it's pretty complicated, especially for a non-linguistic to look at. Mm-hmm. So I couldn't have a very good sense of how complicated. The code are very, very clear written though. So you can kind of reverse engineer the rules. The paper, I think they didn't describe clearly enough every single rule. So I can only partially answer this question. I guess I have to make a disclaimer, although I want to emphasize the importance of linguistics, but I'm not linguistic myself.
So the original sentence was something like the exhibition, which featured 27 portraits, which opened October 8th. You have to know that exhibition is the subject of open. Okay, so that's interesting. Yeah, that's
I think also the great thing that I think I know what they have, at least first of all, they apply recursively. And also they did have some rules to predict the split point. And then they spend quite a bit effort in order to recover what should be resolve what is supposed to be the subject of the second sentence. They do want to figure out which is the discourse of these two sentences, which is the nuclears.
Yeah, I think that's important because it shows that, I mean, again, well, it would be interesting, as you said, would be to see if the sequence model does it as well as humans do, but it shows a type of knowledge that linguists have that's reasonably complex, and that maybe a computer scientist would think, oh, this can't be done, but a linguist knows how to do it.
Yeah, they definitely took a couple of iterations. So this rule-based system people have attempted in 2000. The previous one I am familiar, also know of, considered like having 70 or so rules. Mm-hmm. It's actually took a PhD thesis to write that set of rules. But this one I found is much finally this method seemed to be mature and mature. And it took a generation of linguists to make this.
Yeah, we have another question in the chat from Tanmay. He asks, what was the ground truth data for the ranking module, and did you collect it yourself?
Oh, yeah, that's a very good question. That's nice to have an opportunity to clarify this. Let me advance my slides a bit. So kind of the ground truth is like it's all relied on, we don't have a score that is kind of like rated by human. Instead of what we have is a normal parallel corpus. You have a sentence and you have a human writer written simplified sentence, corresponding simplified sentence, right? The scoring function we are using is try to capture the similarity between the intermediate kind of output we have and the similarity to the human references. So it is an automatic score measuring the similarity between the desired output and yeah, okay, I think, okay. That's a very good question. Just feel free to stop me or by voice or like in the chat. So once we have a scoring function, we're trying to basically let our model to learn how to rank this candidate based to kind of, in order to, at the test time, also pick the candidate that's similar to what human would do. So this is just like a margin ranking loss, but more known as a hinge loss used here in order to let the model learn the scoring similar to the desirable score we wanted. So it's a pairwise ranking situation. The reason we choose pairwise ranking is because many of these like candidates are very kind of similar to each other, especially in the semantic sense. So we want to being able to distinguish which one is even more closer to have a better ranking. It potentially can be used by some other similarity measure instead of the board score to do this. It's also possible that to use a list-wise ranking instead of the pairwise ranking, but we do find the pairwise ranking work pretty well for this scenario. So the kind of feature we use is kind of the like how less similar the length of the sentences and close to the human references. And various kind of similarity measurement, as well as also we kind of capture like what rules apply to come out of this candidate and so on. So it's a small set of feature used here. All right, for the paraphrasing model, we, as I mentioned earlier, we did data argumentation because paraphrase generation is one of the harder part if you work on paraphrase generation. So actually a lot of part of my research on semantics and is actually doing paraphrase identification, how to kind of capture sentence level paraphrases in the world. It's very hard to have high quality paraphrase data set. I think the currently most commonly used one is called NMT created by John Waiting and his collaborators. But it's used basically pretty much translation system to create it. So it's kind of a synthetic data. For this kind of high quality human-made generation, like paraphrase data, is very hard to obtain. So that's why we want to do this kind of data argumentation to kind of make the most out of the data we have. So that's basically the primary motivation behind this. Besides that, we also kind of try very hard to want to add some control into the generation model. So we actually found is there's a few simple things can actually control the model file. One thing is that you can add a vector in order to kind of specify how much amount of word you want to keep in the output, right? So it's kind of, if you specify like 70% as a copy control, the amount of word you want to copy. So that's basically saying like trying to encourage the model to reword the other 30% of the word. This is similar to the massively kind of number of languages for multilingual translation. So this actually simple thing actually worked pretty well. Another thing we did is that we did have an auxiliary task, basically try to identify and rely on an external monolingual word aligner to figure out what word exactly being copied, especially when there are the same word appear multiple times, more than once in the sentence. We want to know which one is deleted, which one is not. So that seemed to help a little bit as have some. So actually that's more like a monolingual word alignment is much more related to semantics. So actually my other PhD student, Wu Weilan, we are having a state-of-art word alignment model in the making. So I think that's probably work right up quite soon. So that's normally kind of a based on a semi-CRF model in order to do this. So it's a very different type of models. Some question on the chat. Tammy have a question. Do we observe scenarios when the content changes in the paraphrase generation? Content changes. Yes. Okay, sometimes the meaning will derivate. Or sometimes it's actually you say the meaning makes sense, even the substitutions are making sense, but potentially model substitute two different noun phrases, but then they put together somehow doesn't make a lot of sense next to each other. So if they only substitute one of them, in the context seem to be smooth. But so for example, if like they will say, I have some good example, but I couldn't remember the exact word. So basically, if like a two noun, like A is a subset of B, right? And then somehow A they resolve to a C, which is also a subset of A. And then he also resolved to C. Then it's the original sentence is A is some B, and then the simplified sentence will become C is C. Then it doesn't make sense, you know, although they are kind of hypernyms of each other. So some example like that. So yeah, a lot of times you can say the model are doing pretty well, but it's just short of a little bit, just make the whole sentence that isn't ideal. So here are some example outputs. I will let you, I think I have time, I will let you look at this for a little while. I think this is the advantage of having a Zoom, so it's fairly big on your screen. I think it probably wouldn't work on the projector with this amount of text. So there's two set of sentence. So there's basically two examples. The complex is the role of complex is the input sentence. The simple is a human reference. And for our model, the CP is the amount of copy. So it's like 60% we ask the model to paraphrase 40% of word. So this you can control that. And the second part of the example, this one we didn't ask the model to split, to force it to split. The first one model is we are controlling whether to split or not. For the first example, we are showing the splitting capability. So the red are marking the arrows, and the blue are marking the with bar, fairly good about the output. So I think the second example of like expert say China's air pollution extract a tremendous toll on human health. So they kind of converted like it's a big problem for human health, right? So it's kind of pretty fluent, and I would think if I explain to a kid that probably use this phrase, that probably work. Yeah, of course, this is fairly cherry pick, but it does like being able to control a lot of aspect of this process to be able to micromanage. Do you want how much you want to delete, whether you want split or not? This kind of you can specify in the model. Still a long way to go to make a perfect model. So I think the idea is for this study. Sometimes when I submit an essay proposal, they will ask you need to do human subject study with children. I actually do not feel that's a need, right? So similar to machine translation systems, you don't need a professional translator or the users like with speaking a foreign language in order to judge whether the model works or not, because it's for a common person, you already know whether they are good or not, as long as you can speak a language. So actually the children wouldn't be able to tell whether it's an error or not to some extent. So this is really trying to mimic professional editors other than, so I think we know what the children need. As a professional editor, already studied this. What we really like is how to develop AI as a real AI researcher or NLP researcher, develop the neural models or models in general to actually make this happen, right? Make this actually as close as possible to the professional editors. And also what I envision this will work is much more so to help people to write faster, right? To help the professional editor to be able to do this job much faster so they can just do post editing, or they help school teachers or the children's parents in order to kind of convert any material their kids are interested in more on demand by themselves, right? Other than have to pay the professional editors or kind of couldn't have the free choice of what kind of article you look like at. Okay, so that's a little bit thought on that. A little bit evaluation. So in the paper, there's a lot of more evaluation. I'm just picking up some of the evaluation to showcase here. So normally evaluation are conducted on fluency, accuracy, and simplicity. For this case, I'm just showing two of them here. It's normally rated 5-point Likert scale. So a little bit background about the state of art we are comparing to. So the programmer interpreter is just like a 2 sig-to-sig model. One is trying to identify they are like what kind of modification they want, if deletion or paraphrase for each word. And transformer is actually I'm going to talk next. So it's like a board initialized transformer. With good data, it's actually outperform anything before this. No matter how there people have been using like reinforcement learning and various different complicated things, it doesn't work as well as just have a simple transformer model with good data. A hybrid is another prior work that combined a kind of a parsing based on the semantic parsing and paraphrasing model. So that's the closest to our approach. Showing a little bit of the capability of model being able to do the syntactic rewriting to split. So our model, when it's required to split, just like we can control our model split or not, right? When we require the model to split, it does like 97% of time can split a sentence. And another thing we're very satisfied with is that 90% of the time is actually correct. It's actually the splitting point and the sleep after the split, the second sentence still look good. Oh, another good question from Taiman. This pipeline is a supervised model. Have we tried models in the unsupervised settings where we don't have a direct mapping of complex simple sentences, but just a bunch of complex and simple sentence? I haven't, my group haven't, but there are other works coming out this year and last year have been trying to do the unsupervised text simplifications. I think it's very interesting, especially for other languages that doesn't have this resource. But I'm a little bit cautious in the way that I really want to, similar to the machine translation work, I really want my the work I do actually impact other people's life. So I do want to go as higher performance as possible to be closely for real world use. But that's just my personal opinion. But on the technical level, I really enjoy those papers which does unsupervised method for this. But my own group actually very good at crowdsourcing, creating very large data set. So I kind of felt like I can make a bigger impact by making supervised models myself, just given the amount of experience we have. But it doesn't prevent other people to pursue the unsupervised method. I may slap my own face. Maybe next year some of my students really want to do unsupervised, we may do it. Yeah, so this is a part we are really pleased about. A little bit automatic evaluations. So we need to take for a grain of salt. Even the evaluation score matrix SARI is created by myself, but I have to admit it's not perfect. Similar to the blue is not perfect for machine translation research. The SARI is not perfect for doing this, but it's good at least like give you a lot of sense of whether your model are going to the right direction during the development stage. So you don't have to do this human evaluation work very so often. I'm going to actually talk a little bit more about this, but just showing a little bit result. For this more controllable kind of generation work, you actually have to evaluate what I think we found most of makes sense is to separate the different operations, to evaluate them separately on different human references, right? So if you want to evaluate the model's paraphrasing capability, you basically want to tune the knob and let your model just primarily doing paraphrasing and comparing to human references that also doesn't contain splitting to have a fair comparison. I think for automatic evaluation, this makes the most sense. So that's basically the idea. For deletion, I just want to add one note here. Deletion ratio, just how much you delete, that impact automatic evaluation, including human evaluation significantly. So it's not fair to compare to a system output that compress 80% versus another system compress 60%, right? They are only fair when they have a similar output length. Right, just one note on this. There's prior word from Christina Tanatova, as well as my former group mate, Courtney Annapolis. They have special papers to address this. So only looking at SARI and one score, it doesn't really help all of that. So actually, in order to fully understand your generation result with automatic measurement, you actually normally need to look several score combined together to get a very good sense. So I'm not going to dive into details of it. This is just part of our paper to do this evaluation make the most sense. So you can see there's SARI actually break down in component, and there are many kind of measurement of like output length and all that to give a full sense of how well the model are doing beyond just besides the human evaluation. So I would just recommend that for any text gen paper, this kind of evaluation are needed to be as thorough as this. And I hope we will have some even better way to do this. Oh, there's some chat questions. Yes. Zhong Zhou has a question. May I ask how you did the human evaluation? How did you evaluate fluency and adequacy? How many people? And what is their level of skill in this language? And how many examples each person take? That's a perfect question. I'm going to talk next. I can answer some of the questions. So human evaluation, the standard used now, again, this is not the best possible, I think could be improved, but the standard one that's currently used in this field is on grammar, fluency grammar, and meaning preservation and simplicity. It just read on 1 to 5. It's actually very subjective. So it's actually the agreement between 4 and 5. How do you rate 4 and 5? It's like, it's very subjective. So the human evaluation has a lot of noise. We are working on improving it. basically need a lot of quality control in selecting cross-sourcing workers. They demonstrate they actually can do this carefully enough. So you can't just run it on the Amazon Mechanic Turk. It's just too noisy. You have to manually select them, each worker almost. One thing we found helpful is actually on a separate note, cross-sourcing workers are great at actually simplify the text. If you give them a sentence, you ask them to simplify the sentence, they do an amazing job. But on reading, they seem to be just clicking a button too fast. So what we currently come out is that after you do research on generation long enough, you accumulate a troop of cross-sourcing workers that are reliable. I don't know that help. So I forgot the exact number of cross workers we asked. It's varies from paper to paper. It's normally somewhere between 5 to 9. The skill level of their language, I think they are just a normal first, because so basically the best worker we found are those ones we ask them to actually simplify sentence and look at the sentence they simplify and they are happy or not, and then ask these people to rate for the human evaluation. So they are I would think they are a fluent English speaker. How many examples each person takes? So on each screen, each question normally we have as normally evaluate 4 or 5 system outputs. Sometimes we provide human references, sometimes not. But we do provide original sentence. We couldn't evaluate more than 5 since at the same time, just because it's cognitively too difficult to look at which one is which and figure out which one is better. Some other people do the pairwise comparison, just 2 systems. They just rate which system outputs better. Is it A better or B better, or they are equally good? So that's another way of doing it. Another question, since simplification models can potentially induce very different output word choices distribution based on how well they learn, is it fair to compare qualitatively analyze on character level or word character length or word length? I guess is that a question about automatic evaluation or human evaluation? So for
yeah, so I meant on automatic, like if you are just comparing the length ratios, as I think one of the automatic measures was based on length ratio. So
yes,
like,
yes, that you were able to spot that on this very overloaded slides. So let me see, I have this huge cursor, which is helpful. So this is output length. Yeah. So this is a sentence length. The reason I have 2 is some of the output have more than, it has a split. So the sentence length will be shorter than output length. So these are measured by the number of words. And then this is the FK. This is a readability measures that combine the sentence length in number of words and plus the length of the word itself. So that's kind of more like a combination of word character length and sentence length.
So is this like Flesch Kincaid or something like that?
Yes, it is.
Okay, I see. Oh, thanks.
I had a hard time to pronounce all the names. Yeah, and then let me see here. So this is comparison ratio. 1 by 1 is just like the same length. So the human reference you can see is actually even add a little bit sometimes.
So these are based on word length, right?
Yes, comparison ratio based on the word length. So only thing consider the length of the number of characters in the word is FK here. And this one is, this is a percentage of sentence we are able to split. And this is soft blue, just measuring how similar the output is to word compared to the input. And this is number of new word added. So it's kind of we want the model to be less conservative, just not keeping the original word. And then this is percentage of equivalent sentence. That meaning basically some of the models you can see, they even keep 7% of sentence entirely unchanged as their output. So we try to want to penalize and show that how conservative each of the models are.
Yeah, so the reason why I felt like asking this question was because, as you said, human outputs are sometimes longer than model outputs. So I was wondering if human editors they actually write more words, but their words are shorter in character length, which is what.
Yes, that's definitely true. That definitely happens. I have to say this is a 3D separate evaluation. There's another combined evaluation. So these are only showing the human that primarily use paraphrasing to achieve simplification. That's why the lengths are kind of maintaining about the same. So do the automatic systems. So here is like we are measuring splitting, primarily those like sentences that professional editor decide to split. So we use this subset of the data to evaluate the splitting capability. And here is kind of more focused on deletion. So this is significant sentence shortened for this set of evaluation. So there is a mixture of things, and there's more actual actual tables in the paper that actually have a combination of all this evaluated all together, use the original combination, like a proportion of the data. But this slides are showing each individual subset of evaluation. So that's kind of why.
Thanks for the answer.
Yeah, thanks for the question. I think the good question make the talk a lot better and clear. So a little bit things about automatic evaluation, this SARI thing I have been talking about. So blue definitely not the right thing. People, I think in my 2015 paper I already said that, and then some other people did even more said that again, and then some recent work rediscovered it one more time. So anyhow, the blue is not the right thing. So the quick answer is that if you keep the input unchanged just as output, you will get pretty high blue because a lot of n-gram will be shown in the human references, but they are now simpler. So that's generally a quick answer for that. So blue only compares system output against the human references. For this text-to-text generation task, one thing very crucial, especially for the readability changes, is really you need to consider how complex the original input sentence is. Right, so you do need to have a matrix that take input into account. So I'm not going to go through this. It looks kind of complicated, but it's actually pretty simple. It's similar to the blue matrix that use n-gram overlaps. So this is just trying to capture what n-gram are deleted from the input by human editors and what kind of n-gram are kept. What are the n-gram being added into this? So I played, so that's I have separate scores and use F measure for addition and F measure for the word that returned and a precision tool for the deletion. I placed the equal weight on this, which I regretted to today. I shouldn't have placed the equal weight. The keep and deletion are much easier and also cannot correlated to each other, but add is actually every model struggling, so they have a harder time to paraphrase. And also paraphrases normally have multiple paraphrases will be all good, right? So it's actually important to have multi-references for this task, ideally. I think it seems to be most of the researchers now agreed on. So the test data people do, most of current work is mostly using multiple references to do this task for human for automatic evaluation. So this is the common setup. Is the paper published since our work on designing the SARI. All the following work are using this, so it's make it pretty easy to spot the result. One work I actually want to mention is Maxine's work. she actually, her and her student actually pioneered in asking crowdsourcing workers to simplify the text, which turned out to be great. And actually her work is kind of sophisticated in a way that they ask people to force people to write a simplified version and ask more crowdsourcing workers to improve on top of that. So I thought that was very neat. It's probably should have been credited even more than it is now. I think the paper was published as HComp. So that's human computer computing conferences. That might be a reason. So I want to shout out for this particular work. That's also inspired us to do this. We did it more concurrently, I think. I only later realized I should have cited the paper, but we may have published about the same time. So once actually you have an automatic evaluation metric, you will be able to actually use it as a training objective if you want to. And some people put it as a part of the reward function that they train for the reinforced learning, which seem to be successful as well. So I'm not going to go into too much detail in this work because they're still using like syntactic statistical machine translation for doing this, but it works. So at the time it was the state of art before the neural model come out. So Google implemented in last year and put it into actually their official release in the TensorFlow, tensor to tensor library. They also use the SARI to evaluate some other text-to-text generation tasks seem to be reasonable for sentence splitting and sentence fusion. So splitting evaluation is still tricky. We are working on that. Splitting probably really need human evaluation at this point. Alon have a question. For automatic evaluation, to deal with paraphrasing and to avoid the need for multiple references, check off comment. Oh yeah, I saw your post on Twitter. I didn't realize that would be the, okay, I marked it on Twitter. I will read it more in detail. How do you compute the commit? I saw the UW have a data set on corpus called commit. Are you guys going to have a duel or something at the EMLP or somehow to decide who keep the name or what?
I haven't seen that confusion, but we'll find a way to coexist.
They are too early, so I think at least they are not a two same model, right? So like learning is like two, both are like pre-trained word embeddings. That needs some really just fight to death. Yeah, we are similar to startups. We are running out of acronyms for all the NLP stuff we are making.
Yeah.
They should have some register or something. You can pay ACL for a little amount of money to keep your name or somehow, and then we can use the name to support other kind of some certain countries or researcher to attend conference or something. Should charge you guys more. Okay, all right, that's a cool work. I'm going to look forward to read about. All right, let me just quickly check the time. Okay, time-wise is getting. I need to speed up. So quality, the data is really important. I want to make that point. For the audience here, it probably doesn't need to explain that. You need to do sentence alignment to get the pair of sentences. In this case, also contain the sentence splitting that will be 1-to-2 mappings from the articles, because the article only come to pairs of document. So you need to figure out which sentence will align to which. Ideally, one day we will do document level generation, but we are not there yet. So there are two major sources, Newsela and Wikipedia, to do this. Just a quick view of this. There's a couple of work I tried to do this before. Actually, I wrote the first aligner for doing this in 3 days, probably even less. So it's pretty high precision. At the time, there's no evaluation data. I just eyeballed it. It's surprisingly, after we labeled data, we tested it. Actually, precision-wise, I did pretty well. I lost a little bit splitting and recall there. But I saw that there are people who would have fixed it in the past 5 years, because the first aligner I written in 2015, but it's not. So when I got my third PhD student assigned this job to improve it. So long story short, it worked pretty well. We labeled some data. The label is annotation task is a little bit tricky, but we got it. And so we fine-tuned the board. It worked pretty well. And we on top of that, we have some paragraph level alignment that help improve the precision quite a bit. And then we have a structure prediction, simple neural conditional random field aligner that kind of push the performance really high. So we're really pleased with this result. It's actually fixed a lot of problem existed in the data set. So just walk you through quickly what happened. So we manually labeled 20,000 sentence pair and 10,000. So for Newsela and the Wiki separately. And then we trained a neural CRF aligner. And then we apply this trained aligner to the rest of the unlabeled data. So we derived two corpus. So both of them are about 500,000, which was good enough to train the transformer models with a lot of more parameters. Seem to be crucial, the size of data for this. I think MT people know better, you need at least 1 million sentence pair. So this is the annotation interface we designed. This is actually done on figure 8. Now it's called APEN, so also called previously called Crowdflower. So I use my awards for doing this. Yeah, so this is the annotation data interface. It works really well, and the quality control of the platform is pretty good, super helpful. So we finally got this done. There's actually a second annotation interface, actually is used in-house. It's on the document level, let you see which sentences are aligned. My student did a visualization. So basically, even after the crowdsourcing, we'll ask the in-house annotator to further inspect the errors, if there are any. So it's a pretty high quality annotation we did. So first of all, when we try to do the automatic one, we actually aligned the paragraph first. The automatic alignment at the paragraph level are more reliable than the sentence level. So there's a little bit here based on the phantom board to measure the sentence similarity to do this. So there's some detail about the algorithm showing here in the paper. And after we aligned the paragraph, we try to align the sentences. So it's kind of, if there's n sentence in the paragraph, we do a n square alignment. So the CRF work like this. So the label, we are mapping each sentence in the simple side to the sentence in the complex side. So the label we try to predict the basically the index on the complex article side. So that's basically the deal. Two scoring are used to do this. So one thing is a phantom board on the label data to measure the semantic similarity between the sentences, and the other one is just the alignment label transitions, right? So basically, you rarely have far-reaching jumpings between the sentence alignment. So if the sentence are aligned to a nearby sentence, it's more likely to align to the next sentence next to it, or the same sentence if in case it's a splitting case. So the harder part is the sentence splitting, actually, because that will be kind of partially aligned. So the similarity score wouldn't super high. So a lot of difficult challenges for this task is dealing with the sentence splitting cases. Just show off a little bit of the real improvement on the data side. So the previous work people are using is like the Wiki large, which is really problematic. The reason is I actually wrote the entire paper debugging not using the Wiki data to do it, but right after the paper, some people and then the other work come out and put all the Wiki data together, and people continue using it. But anyhow, so what happens with Wiki large is the alignment wasn't good, right? People just use some TF-IDF based off like aligner to do this. And another thing is like Wikilarge in particular is a concatenation of the data set released from 3 previous papers that use Wikipedia. It's a simple concatenation of 3 different data sets. So You can say that 30 of them are alignment errors. So those two sentences actually don't mean the same. And 18%, although they are aligned, but they are actually now simpler. They could be almost identical sentences. Just because the simple Wikipedia editor, they are they are not professional editor. There's no restricted guideline for them to have to simplify every sentence in the Wikipedia, nor they have to write a sentence mapping to the original, the standard English Wikipedia. They can just write an entire new article. So then that's one of the issues. But I think we are getting pretty good. I think the model we trained, as you see here, the errors are reduced to only 4%. Even though now simpler, at least they maintain the meaning the same. So actually, before, if you train a model on Wikipedia, you have sentence output, it doesn't look very good. But this year, the new work we train, you can see the model output, it look much more reasonable. We felt like this is pretty good for the wiki data, which is not probably created without a strict guideline. For the New Zealand side, it's of course definitely better because it's done by professional editors. Really, it's restricted guidelines. First of all, is the size from the original version we had is much bigger. Of course, also because this company grew in the past few years, so they were able to have more editors, so it got more data in the number of articles. We of course also were able to align more sentence splitting cases, those tricky cases. You can see that now you have a lot of more data that have this very complicated rewritings. Before we lost it because the more significant rewriting happens, the harder to align them reliably. So there's very few errors in this data set now. I want to show you this. It's like how much difference you can make by just changing your data. So these are models we compare with the word initialized transformer based on Google's work. But this is first time we apply this model on some text simplification. There are a few other previous state-of-art models they compared with. So this is SARI score. Yeah, it's the red bars are trained on our new data. The bar is trained on the previous data. So this is the same mode, 3 models compared as training on different data, the improvement. And human evaluation, which is more reliable, you can see the same patterns. So we actually use the system output shared by the previous authors. So it's not a re-implementation, it's their own models output. So yeah, so this is about what you can improve. So by just changing data. All right, I think this is the last slide I have. I'm not going to talk about this work, I just want to mention it in case that is to your interest. So my student Monica also have a lightweight method. So this is basically primarily lexical phrase level paraphrasing. We do have a lexicon, like 15,000 English words rated by multiple non-native speakers under complexity levels, and also a neural model ranking to measure the phrase and word complexity. So that summarizes the work. I hope I made a point that data is important and linguistics can help. Yeah, I think I'll take some final questions if there are time.
Okay, I'm clapping for everybody.